You guys both play games?
Yeah.
Okay, it's a big industry. It's roughly the size of the movie industry now. It's like a $10, $15 billion industry. Various universities, including my alma mater, Carnegie Mellon, you can get a degree in video game design. I used to laugh at the Russians who used to have you could get a PhD in chess. I think you still can. But the other point is that video games use many techniques that are useful in many other areas. They use graphics. They tend to use object-oriented design. And we'll talk a little bit about the principles of games. One thing, it applies to games, but it applies to many, is a classic partition of the problem, dividing the problem into three components, which hopefully are fairly independent of each other. So in a larger programming organization, these might be separate people or even separate departments who have to work together to produce a game. Okay? So by the way, what games are you most interested in playing? What do you play?
LOL.
Like, what is it, like piloting? Like airplane?
Okay, flight simulators, a classical.
Yes, yeah, like those stuff.
I'm very interested in the technology of game, but I'm not much of a game player. I'll play it a few times just to get an idea what it is. And then I kind of lose interest. How about you?
Shooting games?
Okay, shoot 'em up games. What are some of the Line of Duty or whatever?
Call of Duty?
Call of Duty?
Wow.
Shows you how much I know. Yes.
Online.
Okay. There's some fundamental principles in games. And so one of the ideas is to divide the programming problem into three parts. One is an internal model that basically represents the state of the game as it is now. So if you have a shoot 'em up game, you have players, right? You have some sort of geography over which things are going. Okay? And so we can talk about some way of structuring all that data, about what is the current state of the game, right? The other is the view. For the game to be interesting, there must be some way of displaying the state of the game. And for a shoot 'em up game, it's graphics. Actually, for Flight Simulator, it's also graphics. So how do we draw things? We have moving things on the screen. We may have a simulated 3 dimensions. Your screen, of course, is 2 dimensions. But the world in which you're doing your shooting or doing your flying is 3 dimensions, right? Okay, so that's the view. We're going to talk about a particular application called, or particular built-in library called tkinter. Tkinter comes packaged with Python. If you've downloaded Python, at least a recent version of Python, you've got tkinter as part of it. There are other libraries. There's something called Pygame, which I'm not an expert on, that are specifically designed for games. But we're going to mostly stick with tkinter, except for one example, which I wrote before I knew about tkinter. Okay, so the other is the controller. And that is, how does the player interact with the game? And so this involves a graphic user interface, typically buttons, typically responses to a mouse or a game controller or a touchpad. But somehow or other you interact with the game, you give instructions to your players, and they have to respond, right? Okay, so let's start a really simple game, tic-tac-toe, and let's just play it first, and then we'll take a quick look at the code, because the code's fairly straightforward. Okay, I'm going to run it first. That screen has a little delay, so it's hard to use a mouse. Okay, so first thing it does is it prints a tic-tac-toe board, and it identifies each square with a number. So you be player 1. Where do you want to put your piece?
1.
Okay? So if I say 1 here for player 1, okay, notice there's an X now where the 1 used to be. You be player 2. Where do you put your piece?
5.
5, okay. So player 2 plays 5. Player 1, notice the O went where the 5 was.
Okay, 9.
Okay? Now let's look a little bit about the style of the game. So this is not a very graphics-oriented game. This is really a printer-oriented game. So our view is really primitive here. Okay? Similarly, our controller is basically the console. We're just entering a text, which happens to be a number, and we'll look later when we look at the code what the model is. But I'm imagining the model is some sort of, essentially a matrix, an array, two-dimensional array. All right, player 2.
6.
6. Player 1.
4.
Player 2.
7.
3.
Okay, I think player 1 has won the game.
2.
Okay, I think you've lost. Do you want to resign the game?
1.
Go ahead.
8.
Tie, yeah.
What?
Only one. Isn't there only one left? 8.
Tie.
No, it's a tie game. Okay, sorry.
没人说这赢的，这是。
Okay, player 2.
没错。
Is there any places left?
No.
No, you need
Yeah, it's actually a bug in the game, right?
no ending.
这个没有太看。
Okay, it's a tie game. All right, so that gives you an idea what the game looks like externally.
跟你讲，这个游戏是赢不了这游戏。才赢。
Okay, let's take a look at some of the code for the game. Can we read that? Is that big enough? All right. So there's a comment. It's always a good idea to comment. By the way, this triple quote is a way of commenting a large section. And if there's a triple quote at the front of the code, there's something, no, never mind. That's true of Java, not this. All right. So they're bringing in something called the print function. I'm not sure what that is. We have choices, which is initially an empty array. And we're going to append a string, essentially x plus 1. So x plus 1 starts at 1 and goes to 9. And he's basically putting those in the choices array. So we have a variable called player1 turn. It's either true if it's his turn or false if it's the other player's turn. And initially there is no winner. Okay, so this is really where the game is displayed. So we print a /n says go to a new line. There's a bunch of minus signs. And this is the top row of the 3x3 array. Okay, and notice that the choices are placed there. So initially, they're just the numbers 1 through 9, if you recall. Okay. Okay, so we have a while loop. So basically, while there is no winner, remember winner starts at false. So essentially, it'll stay false until somebody wins. Okay, we're going to print the board. If it's player 1 turn, we'll print player 1 prompt. Otherwise, player 2 prompt. And we're going to try to get an input. So input will prompt that and basically waits at the console for a response. When you respond at the console, what you're delivering is always characters. Okay? Character string. Can you read this? Should I make it bigger? Or do you want to move closer? Maybe that works. All right. So we're converting now input into an integer. You've got to try except if the person enters something that can't be converted into an integer, there will be an exception. And basically, I guess he'll go around the loop again. Okay. So if the choice is, okay, okay,
Also,
what is being checked there?
it's already taken.
Yeah, I think that's the case. You can't basically make a move on a, good, yeah, thank you. All right, all right. So if it's player's one turn, then his choice gets an X. If it's player's two, it gets an O. Okay, once that's done, in essence, we flip who's the player, because it's just a Boolean deciding who's the player. And now we're gonna check to see if we have a winner. And so he's got, essentially, all right, so if he's got 3 in a row in the Y direction, which is vertically, that's a winner. 3 in a row in the X direction, that's a winner.
Two course.
Excuse me?
Then next to two course is the same. Course is the same.
Yeah, I think that's what's going on right here. Yeah, these are checking for the forward diagonal and, or downward diagonal and the upward diagonal. So if either of those are all, okay. And that declares a winner, and then I'll print the board. So it's pretty straightforward. There's nothing too fancy there. A lot of conditions have to be checked. Any questions about the notion of an array here? Because we are setting up an array. It is a 9-position array. And pretty straightforward. Okay? All right, let's go to the next problem. This is find my game. What happened here? Lander, I just ran it. Find it again. All right. Gotta find this piece of code that I found this morning. Sorry about this, I have to set it up. Probably a better way to do this. Okay, let's see if I can do this. It's gonna want me to save it someplace. And, all right, we'll just call this rocket. Okay,
Whoa.
all right. So this is Lunar Lander. Okay, so this is a graphics program. This one almost the first graphics program I wrote, and it actually doesn't use Tkinter, it uses another package. But the basic idea is we have a lunar lander, and it's operating under the force of lunar gravity, but it has rockets, and it has an initial velocity, an initial altitude, it has a certain amount of fuel, and the idea is we don't want to crash onto the lunar surface. So notice that there's an image there, it's being updated in more or less real time. I'll show you how that's done in a moment. Notice a little animation on the rocket tail, the rocket. Now, right now it's just operating. Notice the force is 0 because I'm not firing any rockets. But I'm going to fire some rockets. First of all, I want to slow down its motion to the right. So I'm going to hit this button over here. And secondly, I want it to begin descending. Okay, so that's about halfway down. It started at 10,000 meters. It's now at 4,400 meters. It's now descending at 17.3 meters per second. My criteria is it's got to be hitting the ground at less than 10 meters per second, or otherwise it's a crash. Okay? So it's going a little faster than I want it to do, but I'll let it get closer to the ground before I do this. Okay, it's still moving to the right. So let's take a little more to the left. And I'll start slowing it down, well, when it gets to a couple of thousand meters, which is about almost there now. We'll start slowing it down. Okay, notice the fuel. So basically, the more force I give the rockets, the more rapidly I burn the fuel. And if I run out of fuel before I hit the ground, then that's a crash. Okay. I'm going to slow it down now. I've got to get the speed under 10 in order for it to successfully land. And notice the speed is dropping. I'll try one more. And looks like the game is stopped. I don't know what's happening. It used to pop up a window that said either you crashed or a game. So let's take a look at that game. All these games. All right, let's take a look at it. Oh, this one does use Tinker. Yeah, that's right. Originally I was not, but then I modified it to run Tkinter. All right. So it turns out I kind of stole this from someplace else, the Tkinter part. There are two versions of Tkinter, and we're running 3.6. So actually it tries both. One of them will fail, and the other will work. Okay. So I probably should get rid of the first one. I don't need it. All right. So we have a number of methods going on. One of them is drawing the flame. Remember the flame coming out of the bottom of the rocket? So basically what that is, Tkinter has a number of objects. We'll talk a little more about objects, but one of them is a polygon. So effectively this polygon is a triangle. So it takes as an argument the rocket's x-coordinate and y-coordinate. And it basically draws a triangle that's very long in the y direction, but only -5 and +5 in the x direction. And it sets the fill to be orange, so the triangle will be filled with orange. And then it draws it in the window. Okay? Then it sleeps for some period. Actually, this is in units of seconds, so this will be 10 milliseconds. Okay? It sleeps for 10 milliseconds and it erases it. It undraws. F was the name of that polygon. It's undrawing it. That means it erases it. Then it draws another polygon. And what's the difference between the two polygons?
It's red.
Yeah, okay, this one's red, but I think it's also slightly different in its geometry.
Smaller.
Yeah, notice that the +5 is no
It's
longer.
narrower.
So basically, there are three triangles that are sort of going like this every millisecond. All right, that one's red, and then it does another polygon, and there's something different about that one, and it's set to orange. Oh, we undraw it, we draw it, and it keeps sleeping. So basically, there are three triangles, red and orange, that are kind of flipping back and forth at 1 millisecond. Gives the illusion of a rocket exhaust. Okay, now, okay, so I migrated this over from non-Kidder to Kidder. I would not have done this way if I was designing it in the first place. To Kidder, essentially, the package I had didn't have a notion of a button. But it did have a notion of where have I clicked the mouse, okay? So basically I defined a bunch of rectangles, one of which is essentially the whole screen, which is the sky. And then there are these 4 buttons, which represent the 4 buttons that I control the rocket with. And they have a certain geometry. And I'm going to draw them. Okay, and I have a routine called getMouse. So I'm declaring some variables to be global. That means they're known outside of this routine. And these are the rocket force in the x direction, rocket y. Okay, there's a little bit of physics going on here. Basically, Newton's laws. An object will continue in motion if there is no force. Okay? Its velocity in the x direction and y direction will be the same as long as there's no force. If I apply a force, I'm going to accelerate it. I'm going to change its velocity. Okay, so this is going to be the forces. So what I'm going to do is I'm going to check my mouse. And mouse XY is the point on the screen where I click the mouse. So I have an XY coordinate. And I basically say that if that is, okay, if it's none, one possibility is I haven't clicked the mouse in that interval. But if it's greater than 120, I'm really away from all my buttons. So I sort of randomly click my mouse somewhere away from buttons. I don't care if I did that. Same thing, greater than 70 return. Okay, if, what I'm basically doing is saying in which of those rectangles did I click my mouse. So I determine which it is, and I appropriately increment my rocket force in either the y or the direct. Okay, so basically, if it was the top button, I'm going to increment my force by 10. If it was the bottom button, I'm going to decrement it by 10. And similarly in the x directions. So this is kind of the way I'm simulating a button. Later on we'll talk about directly a button. I'm going to define a routine called format, which is just pretty prints a real number. This is a format code. So it's going to reserve 6 spaces for the number, with 1 space to the right of the decimal. And it's expecting a floating point, and that's what x. So just, I gotta print a bunch of numbers rather than throwing format codes everywhere. I get it in one place. All right, draw the text. Okay, you remember at the top of the screen, you were seeing a little display of the velocity, the altitude, the force, and the time. Okay, so what am I doing? I'm really starting with a string. I have a constant. I'm formatting. In this case, we're talking about velocity. So this is the rocket's velocity in the x direction and the rocket's velocity in the y direction.